There are two final concepts that we're going to address in this unit. They are summation and series, and they are almost the same thing. The difference is that summation involves just adding a finite number of terms, and a series is something that you can't actually do super well until calculus, but there are a few series you might be able to tackle right here, right now. And so I'm really interested to see what you can do with them. But let's start with the basic definition of what's going on here. So summation just means take a sequence and add up the terms so that you find what the sum of that sequence is. In this case, to do this is really, really simple. There's like not a formal process that you need to do. You guys know how to add. So 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25. And this, like, summing something up that is finite like this is so tedious to write out that a lot of times what you will see happen is instead of presenting it to you in a like a declared sequence like this, 1, 3, 5, 7, 9, what they will do is they will write a sum as a notation using a Greek letter called sigma. So the way that sigma notation works is they will first use this big E-looking thing, which is not an E at all. It is an S. It is a Greek letter S. The name of it is sigma. And since summation starts with an S, sigma makes a lot of sense for this. So, sigma means that you're going to add up all the terms of the series, whatever it is. And it will actually tell you where to start. So if we are starting at a sub 0, and we are going to a sub 1, 2, 3, 4, a sub 4, then the way that I can define this is I will start down here and say we're going to go from n equals 0, and we're going to go all the way up until the fifth term, which has an index of 4. So going from 0 to 4, and then we use the explicit formula from earlier. I can find any random term for this series. There's sequence. I do that all the time. If I mix up the word series and say it when I shouldn't, you guys can, smack me on the back of the hand. That's fine. Let's define this sequence explicitly. So any term, a sub k, can be found by plugging in k, and let's see, so the initial term was 1 plus, each one is a plus 2, so 1 plus 2k. And let's check this, a sub 4 would be 1 plus 2 times 4, a sub 4. So that's 1 plus 8, which is 9, which is the fifth term, a sub 4. Cool, so this works. So if my explicit definition of this sequence is 1 plus 2k, then I can take that and plug it in over here, 1 plus 2n. I've swapped the letter k for n over here just because that's what most mathematicians use to denote the difference between a sequence, which is just tell me the numbers, and a summation, which is tell me what all these numbers add up to. So the way that you would do this is basically this means plug in every number from this one to this one, and then add. And we'll look at what this looks like in a moment.